Hey guys, welcome to video 2 for this week. So today we're talking about segments and congruence. Okay, so this is a concept that we talked about in the last video. When 3 points are collinear, you can say that one point is in between the other two. Remember that collinear just means they fall on the same line. So here we have points A, B, and C. So A and B are a line segment of their own, and in between them we have point B. But if we look over here, D and F are connected on the same line, but E is not on the same line, so it is not collinear with those. This leads us into what is called the segment addition postulate. So it says if B is between A and C, meaning between as in collinear, then AB plus BC equals AC. So this is just saying that the value of AB, so the distance from A to B, plus the distance from B to C is the same as the distance from A all the way over to C, which makes sense. Okay, it's just adding the two small chunks together and then putting it and adding them up and getting your final answer. So here is our first example of this. So we want to use the diagram to find GH. So GH is this distance from one point to another. So we already know that from F to G, it's 21. So we've gone 21 units. We need to figure out how much further to get to the full 36, because that's the total distance. So we can label this with a variable, because we don't know what the value is. So the segment addition postulate says AB plus BC equals AC. So in this case, this is our AB plus BC equals AC. We can replace this with one small segment. So FG is 21. X is the one right next to it. And then AC is the total distance, which is 36. So if you remember, how do you solve for a variable? We got to get rid of that 21, and we get X equals 36 minus 21 is 15. So GH, the distance between those, is 15, which makes sense because 21, 15 together, they make 36. Line segments that have the same length are called congruent segments. In the diagram below, you can say the length of AB is equal to the length of CD, or you can say AB is congruent to CD. The symbol congruent means is congruent to. So this weird little symbol here that's an equal sign with a squiggle over top, that's called the congruent symbol. We're definitely going to use that a lot throughout the year. So make sure that you're familiar with that. Okay, so this is lengths are equal, AB is equal to CD, and segments are congruent. So if you notice, the only thing that's really different besides the symbol is the fact that there's no bar over top of AB and CD on the left side, but there is a bar over the top of these ones. The reason is because when you're talking about lengths of segments, you leave the bar off. You're looking for like the numerical value that's a distance, so like inches, centimeters, something like that. But when we're talking about the segments themselves, we don't necessarily need to know their lengths, okay? We'll practice this more and have a conversation in class about the difference if that's a little confusing, so don't panic too much. But just know that if there's no bar over top of them, it's looking for the actual number value. All right, use the diagram in the segment addition postulate to find the value of x and the lengths VW, WX, and VX. Okay, so now this time we don't know any specific values, but we're trying to figure out x itself. But if you remember, the way that I always think of it is, look at what is the big segment. So the big segment is from V all the way over to X, and that value is this right here. So we know that that is what everything has to equal. Then we have the two small chunks. We have V to W, and then we have W to X. So together, by the segment addition postulate, we add those two values together, which is the 4x plus 2 and the 8x minus 4. I'm going to add those, and together they should add up to be the 10x plus 6, which we already said is the whole thing. 8x minus 4. Okay, so now I'm just going to combine like terms. So on the left side, I got this 4x and this 8x, gives me 12x. And then I got the positive 2 and the negative 4, which gives me a minus 2. Now it equals 10x plus 6. Okay, and then we just keep solving. So I'm going to get my x's on one side. I'm going to subtract 10x from both sides. I get 2x minus 2 equals, what's left on the other side is just 6. Now I'm going to add 2. And I get, this is going to go away, 2x equals positive 8. Divide by 2. And we get x equals 4. So no, that's one answer. That's not the final answer. This is another thing you'll have to get used to with geometry. A lot of the times we're going to solve for a variable, but then we got to plug it back in. So I figured out that x is equal to 4, but I need to figure out what are these lengths right here, VW, WX, and VX. To figure out the lengths, which is the number value, I need to plug 4 back in. So VW, WX, and VX. To find VW, let me erase some of my squiggles here. So VW, I'm going to plug, that's from this one to this one. So if I plug in 4 in place of that, I get 16 plus 2, which equals 18. So VW is 18. Next, I'm going to plug in 4 for this x value. 8 times 4 is 32. 32 minus 4 gives me 28. Now there's two ways you could do the last part. Vx is the biggest part. Now that we know what the two small chunks are, you can just add those together. 18 plus 28 is going to give you 46. Or you could plug in 4 in place of the x here. 10 times 4 is 40, and 40 plus 6 is also 46. But this is our final answer right here. And these are just in units because we don't know if it's inches, centimeters, but you don't have to worry about that right now. Okay, that's it for this lesson.